So students, next let us start exercise 13.2. 13.2. Okay. So 13.2. One interesting sum we'll do. Number 2. So Rachel, an engineering student, was asked to make a model shaped like a cylinder with two cones attached at two ends by using a thin aluminum sheet. The diameter of the model is 3 cm and its length is 12 cm. If each cone has a height of 2 cm, find the volume of air contained in the model that Rachel made. Okay, so let us do this one. Without this diagram, we are not going to understand. So, for the proper understanding, we must do the diagram. Okay. So, the total length of the model is how much? Total length of the model is 12 cm. Total length of the model is 12 cm. And each cone has a height of 2 cm. Each cone has a height of 2 cm. This side also 2 cm, and the diameter of the model is 3 cm. Diameter of the model is 3 cm. Okay. So we have to find out what is the volume of air in the model that Rachel made. Okay. So for the cylinder, height capital H is equal to 12 minus 2 plus 2, 12 minus 4, it is 8 cm, and diameter is equal to 3 cm. Therefore, radius R will be 3 by 2 cm. Okay. So for the cone height H is equal to 2 cm, radius R is equal to 3 by 2 cm. So then, therefore, volume of air contained in the model is equal to volume of air contained in the model is equal to 2 into volume of cone plus volume of cylinder. 2 into volume of cone, 2 into volume of cone plus volume of cylinder. Okay, 2 into volume of cone. What is the volume of cone? 1 by 3 pi r square h. And what is the volume of cylinder? Pi r square capital H. Remember the difference. Students, small h is the height of the cone and capital H is the height of the cylinder. Okay, so this will be from there. If I take pi r square common, then I will get Small h is 2 and capital H is 8. Okay. So with this 2 you cancel 20 to 11 times. So 9 into 11 is 199. And 7 to the 14. And inside 4 plus 4 by 3 plus 8 by 1. So students, here we just change the units, volume, so this will be centimeter cube. So previously we were doing surface area, so this is volume, 66 centimeter cube. So let us see, this sum is like this students. Rational and engineering student was asked to make a model shaped like a cylinder with two cones attached at its two ends by a thin aluminum sheet. The diameter of the model is 3 cm and its length is 12 cm. If each cone has a height of 2 cm, find the volume of air contained in the model that Rational made. Okay. So just imagine the shape is just like this. This is the cylindrical part, and here one cone is there. Okay. Just imagine the model. This is the cylindrical part. Here one cone is there. On the other part also one cone is there. Understood? Just so simple. The model is made this way. On this part, on this end also one cone is there. And on this end also one cone is there, and the middle part is a cylinder. Okay, so let us discuss that. So this is the cylindrical part. On this end one cone is there, on the other end also one cone is there. The height of this cone is 2 cm, and the height of this cone is 2 cm. It is said in the question, you see, each cone has a height of 2 cm, and the length of the model is 12 cm. From this end to this end, the total length is 12 cm, and the diameter of the model is 3 cm. Diameter of the full model is 3 cm. From this point to this point it is 3 cm. Okay. So for the cylinder, let us see what will be the height of the cylinder. Height of the cylinder will be from here to here, isn't it? So what we did is what is the total length of the model from this point to this point? It is 12 minus this height is subtracted and this height is subtracted. So middle cylinder height will get to. So I just added the height of this cone and the height of this cone, and I subtracted from the full length. So 12 minus 4 is how much? 8 cm. So therefore the height is much height. From here to here it is 8 cm. Okay. And diameter of the model is 3 cm. So diameter of the cylinder also will be 3. This part from here to here is 3. So if the diameter is 3, what will be the radius? 3 by 2. For the cone, height of the cone is small h, 2 cm, and the radius will be what? 3 by 2 cm. Therefore, volume of air contained in the model, students. Volume of air contained in the model is equal to what will be the total volume of air inside this model? What is the total volume of air inside this model? Here this sentence you see, assume the outer and the inner dimensions of the model will be nearly the same. That means the dimension that we are taking. Think that the sheet is of very thin size. Therefore, outer and inner dimension we don't consider. Just you have to find out the total volume of air inside the volume. So how will you find out, students? Here you see, here one cone is there, here one cone is there, here also one cone is there. Therefore, I have 2 into volume of cone. Because how many cones are there? 2 cones. So left side also one cone is there, right side also one cone is there. So 2 into volume of cone, and middle part one cylinder is there. So 2 into volume of cone, plus volume of cylinder. What is the volume of cone, students? 2 into volume of cone is 1 by 3 pi r square h. The formula is 1 by 3 pi r square h. And what is the volume of the cylinder? Pi r square capital H. Remember to write the things properly. Height of the cone was small h and the height of the cylinder was capital H. So write it that way. Okay. So from here I can take pi r square common. From here also I can take pi r square common. From here if I take pi r square common, what will stay? 2 into 1, so 2 by 3 will stay and along with that h will stay. From here if I take pi r square common, capital H will stay. Now just put the values. In place of pi you put 22 by 7. Radius is how much? What is the radius? 3 by 2. So r square, so 3 by 2 into 3 by 2. And 2 by 3 into what is the value of small h? 2. And what is the value of capital H, students? 8. So write here 8. So 11 into 3 into 3 will become 99 and 7 into 2 will become 14 and 2 into 2 it will become 4 by 3. Below 8 1 is there, so 3 and 1 LCM you take. You take the LCM of 3 and 1, that will be 3. So this 3 will go 1 times in 3, so 1 into 4, and this 1 will go 3 times, so 3 into 8 24. So 4 plus 24 will become 28. With this 14 I am cancelling 28 2 times, with this 3 I am cancelling 99 33 times. 33 into 2 will be 66 centimeter cube. So this is the volume of air inside this whole model. Understood? So next, students, let us see number 4. A pen stand made of wood is in the shape of a cuboid with 4 conical depressions to hold pens. Okay. The dimensions of the cuboid are 15 cm by 10 cm by 3.5 cm. The radius of each of the depressions is 0.5 cm and the depth is 1.4 cm. Okay. So find the volume of the wood in the entire stand. Understood? Pen stand, all of you have seen, I think. Pen stand is like this. Here conical depressions are there to keep the pen. I think all of you have seen. Isn't it? In these places only the pen is. This is a 2-dimensional picture, but actually it's a 3-dimensional thing, isn't it? The pens are kept like this. Isn't it? So the places where the pen should be kept are conical. Okay. So you have to find out what is the volume of wood in this pen stand. Okay. So let us see. Let it be capital H. D also capital and L also capital. See, therefore, volume of the in the entire stand is equal to volume of the cuboid minus 4 into volume of cone. So volume of the cuboid, students, will be L into B into H. Okay. So and volume of cone, the formula is 1 by 3 pi after H. So volume of the cuboid will be, students, volume of the cuboid, as you know, L into B into H, and volume of the cone is 4 cones are there, so I have multiplied by 4. So 4 into 1 by 3 pi r square h. So L is 15, B is 10, height is 3.5 minus 4 into 1 by 3 into pi. This is the value of pi 22 by 7 into 5 by 10 into 5 by 10 into, and depth is how much? 1.45, 14 by 10. So this 7 I will cancel 14 2 times. Next, this 5 I will cancel 2 times. This 2 I will cancel 2. With this 5 I will cancel 2 times. This 2 I will cancel 11 times. So this will be 15, 150, or 15. So cuboidal pen stand is there. A cuboidal pen stand is there like this. Students, here this kind of conical depressions are there where you can keep the pen. Now, how can you find out how much wood is there in this stand? So what I did is I first wrote all the data that is given in first slide. First, if this is happy to develop in such a volume, it will be quite good for you. So first you write the length of the cuboid, breadth of the cuboid, height of the cuboid. For the cone, this is for the cuboid. For the cone, radius you write, and depth. Depth is height of the cone. Now, volume of the wood in the entire stand. Volume of the wood in the entire stand is how much? Volume of the cuboid minus 4 into volume of cone. How many cones are there? 1, 2, 3, 4. Isn't it? 4 cones are there. So, from the volume of the complete cuboid, from the volume of the cuboid, if you subtract all the volumes of the cone, how many cones are there? 1, 2, 3, 4, isn't it? So volume of the cuboid, that means complete pen stand, minus 4 into volume of 4, because the conical wood has been taken out, isn't it? So we have to subtract this. This is volume, remember, this is not surface area. Okay. So volume of the cuboid minus 4 into volume of cone. So what is the volume of cuboid? L into B into H. Why we are subtracting? Because we have taken out the conical. Because we have taken out the conical depressions, so that's why we are subtracting. Okay. So volume of the cuboid is L into B into H. 15 into 10 into 3.5, and 4 into volume of the cone is how much? 1 by 3 pi r square is. Pi is 22 by 7. Radius is what? Radius means 0.5. You see, radius of the cone is how much? 0.5. So write 5 by 10 into 5 by 10, and height of the cone is, height means here depth. Depth given no, that is 1.4. So put here 14 by 10. So just I cancel with 7 I cancel 14 2 times. Then with 5 I cancel 10 2 times. With this 5 I cancel 10 2 times. With this 2 I cancel 22 11 times, and with this 2 and this 2 I cancel. So what is remaining is 4 into 11 above and below, 3 into 10. So with this 4 with 2 I am cancelling for 2 times, with 2 I am cancelling 30 15 times. So 2 into 11 is 22. 22 by 15 is how much? 1.47. So 525 minus 1.47 is how much? 523.53. This is the volume of the wood in the entire stand. Okay. So next, number 8. So spherical glass vessel has a cylindrical neck 8 cm long, 2 cm in diameter. The diameter of the spherical part is 8.5 cm. By measuring the amount of water it holds, a child finds its volume to be 345 cm3. Check whether she is correct, taking the above as the inside measurements, and pi is equal to 3.14. That means inside measurements. Okay. So this is the shape. So this is a spherical glass vessel with a cylindrical neck. Okay. So cylindrical neck, that is 8 cm long, and 2 cm in diameter. Okay. Diameter is 2 cm, and the length of the neck is 8 cm. The diameter of the spherical part is 8.5 centimeter. Okay, diameter of the spherical part is 8.5 centimeter. Yes. Now, a child has measured the volume to be 345 centimeter cube. Let us see. A child has measured the volume to be 345 centimeters cube. Let us see whether the child is correct or not. So, for the cylinder. Height h is equal to 8 centimeters. Diameter is equal to 2 centimeters. Radius r is equal to 2 by 2 centimeter, that is 1 centimeter. Okay. For the sphere, diameter is equal to 8.5 centimeter. Radius capital R is equal to 8.5 by 2 centimeter. Therefore, volume of the vessel is equal to volume of the cylinder plus volume of the sphere. Volume of the cylinder will be you have to take 3.14. Okay, so take the value of pi as 3.14. Radius is how much of the cylinder? 1, isn't it? So 1 into 1 to h is how much? 8, and 4 by 3, pi means 3.14, and radius is 8.5 by 2. So right, 85 by 20 into 85 by 20 into 85 by 20. So what students need to do is that we will cancel with 5. 17 times and 4 times. 4 times. 17 times and 4 times. It's 4 and cancel this 4. Next, anything that can be cancelled. So, okay. This will be 154. 154. So it is 154. This will be 0. This will be 0 and 1. This will be 2 times. This will be 2 times. 2 times will be 96. 96. 96. So 6, 66, 1 times 48, 16, 8, 1, 8. 3 times 144, 2, 9 times. The answer is 321.39. So if I add these two, so I will get 321.39 plus 25.12. 11, 1, 6, 4, 346.51. So no, then you write no, the child is not correct, as the correct answer is equal to 346.51 centimeters. So let us discuss the sum, students. Let us discuss this. So one cylindrical vessel is there, one spherical vessel is there with cylindrical leg. Okay, one spherical vessel is there. The vessel is spherical. I think all of you have seen such kind of vessel. Earthen pots you have seen, no, of this shape. So the main body is spherical, but the neck is cylindrical. Okay, the height of the cylindrical portion is 8, and the diameter of the cylindrical portion is 2 cm, and the diameter of the spherical portion is about 8.5 cm. So a child calculated the volume of water it can hold is 345 centimeter cube. A child calculated this. You have to check whether she is correct or not. So let us check. So for the cylinder height, what is the height of the cylinder? Height of the cylinder is 8, and what is the diameter? 2. The diameter is 2. Then what will be the radius? 2 by 2, that is 1. For the sphere, what is the diameter? You see, diameter is 8.5. The diameter is 8.5. So what will be the radius? 8.5 by 2. So volume of the vessel. What will be the volume of the full vessel? Let us find out. So volume of the vessel will be volume of the cylinder, isn't it? Volume of this cylinder. This part is cylindrical, no? How will you find the volume of the full vessel? So we will just add the two parts. Volume of the cylinder plus volume of the sphere. Understood? How will you find the volume of the full vessel? Volume of the cylinder plus volume of the sphere. So what is the volume of the cylinder formula? Volume of the cylinder is pi r square h. Small r is the radius of the cylindrical portion, and volume of the sphere, students, volume of this sphere will be 4 by 3 pi r cube. Capital R is the radius of the bigger sphere. Okay, so now just put the values. Volume of the cylinder, in place of pi, just put the value of pi 3.14. And what is the radius? Radius is 1, isn't it? So write 1 into 1, and into small height of the cylinder is how much? 8, so into 8 you write. And 4 by 3 pi is value into 3.14, and capital R is 8.5, so at 85, 8.5 by 2 you see here, 8.5 by 2, no, I just remove the decimal and I wrote 85 by 20, 25 by 20 into 85 by 20. Then what I did is, above part I multiplied 3.14 into 1 into 1 into 8 is 25.12, and with 5 I cancel 17 times, 5 I cancel 4 times, same way here also I cancel and here also I cancel. Next I multiply 3.14 into 17 into 17 into 17 will become 15426.82, and below 4 4 are 16, 63 are 48. So 15426.82 divided by 48 is 321.39. So these two I added, I got 346.51 centimeter cube. So to the child, whatever she calculated was 345 kg, so she was not correct. The correct answer is 346.51 centimeter cube. Okay.